right, so today we are just going to knock out a couple quick problems. Do you guys remember doing these in Algebra 2 last year? Okay, so question, we're going to do the graph part, you're going to do the graph part, and then we're going to come back together because I want to talk you through, depending on how you shade stuff, these graphs can get awful. So I'm going to try to show you a way that we don't have to do all the lines and shading and hashing and stuff because there's better ways to do it. But we'll see what you guys come up with. So here we go. I want you to solve each of the following systems of inequalities. And here we go. For the first one, I want you to graph it, but I want us to shade it together. Okay? All right. Three equations, and I'm going to use three different colors. Our first equation is first inequality, x plus y, I'm claiming is greater than or equal, there's graph paper there if you'd rather have it, because we're going to be doing a bunch of graphing. It's on that black paper thing there. Okay, greater than or equal to 1, I'm sorry. The second wonderful equation is negative x plus y is also greater than or equal to 1. And the last little piece of this, and let's see, yellow, y is less than or equal to 2. Did you forget your glasses today? You can move the chair to the other side, and then you can move the table however you see fit. Like, you're welcome to. All right, cool. I'm going to pause it here, and I'm going to make it so you guys can't see, but I'm going to show the work in just a moment. Talk it out once you have it written down. I want you to do these sans calculator for now, and then we'll look at how to do these on the calculator here shortly. Cool. Trabaja, talk it out. Checking it out. The very first thought in my head is I need to be careful that I don't get anything goofed up. Is this solid or dashed?
Solid.
How do you know that? Okay, so I like to just put a solid point next to it. What about green?
Solid.
So I'll put a solid point next to it. And what about yellow?
Solid.
Solid. If it's not, like, don't change yours. I just want you to see it because we happen to be doing this one. If it was that, what would I put here? So a dash doesn't make sense, but an open dot would. This is what I would use. Now, if we underline it, then we'll just fill in that point. Okay. We are decided they're all going to be solid at this point. Now, as we look at this, we need to graph all three of them. And if you're looking at this and thinking, well, I don't really know how to graph them, you do. When we graph it, the inequality part just tells us where to shade. I'm going to treat it like it's an equal sign. I'm not going to physically rewrite everything with an equal sign, but we're just assuming it's x plus y equals 1. Now, if I go to graph that, how would you graph that, Christina? X plus y equals 1. What would, like, and I'll write it here. I don't want you guys to write it if you don't need to. How would you go about graphing that? How many of you would move the x to the other side so it becomes negative x plus 1? Can I convince you that there's a better way you think? I guarantee I can. I hope you lean into this because this one's not bad to move the x. It's doable and it's easy. But if this was a 3 and this was a 4, is that as easy of a problem?
No.
Like, they're ugly. But I just want to show you we have a workaround, and it will always work if we get equations in standard form. Okay, I'm going to just draw my coordinate plane. Let's graph the blue one first. Now, what does this graph look like before I even draw it? Not like what direction. Is it a parabola? Is it a wave? It's a line. Okay, so how many points do we need to draw a line? 2. Every line is defined by 2 points. Now, you can have more than 2 on it, obviously, but check this out. Right now, if I'm just graphing this one, give me the easiest x value I could plug in. Like, I'm not going to rearrange it. If I plug in 0 for x, do you guys agree? And, like, normally I wouldn't even write this. That's what it turns into. When x is 0, what's y?
1.
Okay. What if y is 0? Then this would be x plus 0 equals 1. When y is 0, which means I'm on this axis, what's the x value? Do I get 2 points? Do I have to do any algebra and rearrange and think about slope and y-intercept? No. As long as I get 2 points, can I draw my line? Piece of cake. There it is. Now, for this, because we have several graphs, really important. I want you to do this on quizzes. I want you to do this on tests. It's good practice anyway. You should probably label these because you don't have the ability to shade and change colors as easily as I do. Notice I graphed equals 1, but we'll think it out with the shading here in a minute. I want you guys to do the green one using the same method. Don't solve it so it's y equals x plus 1, which is doable, but I want you to pick an x, pick a y, or pick 0 for x and 0 for y, and let's just see what she spits out at me. And it takes like 2 seconds. Alea, if x is 0, what's y? If I plug in a 0 for x, what does it give me for y? 1. So here's 0, 1. And then if I plug in a 0 for y, Addison, what does it give me for x? So you will. All I'm doing is I'm just plugging in an x or a y. What do you get for x if I plug in a 0 for y? You are correct. It is exactly -1. Do I now have 2 points on that line? I plugged in a 0 for x, and then I plugged in a 0 for y. That's all I'm doing. Every single time that I'm given an equation in standard form, that's how I'm going to roll. Every time. Yes, ma'am?
The greater than or less than doesn't matter.
Not yet. It will. Great question. If you didn't catch Leisha's question, she said, so the greater than or less than doesn't matter? Not right now. Okay. The last line, what does it look like? It's a horizontal line through y equals 2. And it's up here. Okay. Now, I'm certain that you guys did these last year. I don't know how much time you spent on them. There's a really common mistake that people make when we're thinking about these, and we're going to see if it can happen. What I want you guys to do is, can you see that there are regions up here? Now, some of them are bounded, some of them aren't. Some of them go forever, I think. What I want you guys to do on your pages is just count me how many regions there are. Like physically touch, count the number of regions that you guys identify. I'm going to give you a minute, check with your neighbors. I'm going to pause it here, and then I'll talk through it. If we're ever talking through a whole problem on the board, I'm going to number it and label it and stuff. You typically do not, just so you know. But anybody not see 7? There's several of you who got more, and I'm going to start with one of those more ones. Now, I'm going to undo all these colors. I just want to make sure we can see them. Okay, I think that if you got more than 7, this is probably what you consider one of your regions. But here's the big question. What are the boundaries? It's only these things, right? Do we have anywhere saying that y has to be greater than 0? So is there any reason for me to stop shading just because I get to the axis? Like, it's another line, but is it one of my boundaries? No, this is one region, all of this out here, and it goes forever. So looking at that, we have that infinite region, and we have this infinite region that's also going to get accounted for, all of that. I don't stop at the axis unless it's one of my bounds. Where's the last infinite region? The bottom. Yep. Now, people will naturally try to shade just a triangle, but there's nothing stopping us from going past it. So there's the last one. Now, I'm just going to number them for simplicity's sake. You know what? We'll do letters. Now, when I do the letters, there's an unbounded one up here too. I happen to just see it. If I'm going to say this is region A, I'm going to make it bold and terrible, first of all. But I'm also going to split the axes. If it doesn't split me, I want to make sure that that's the same region. Here's B. Here's C. D happens to encompass all these regions here. A, B, C, D, E. And one more. And one more. Do we all see the 7 regions? Okay. Now, here's where I don't know how you learned it. I think with Miss Jarvis or with Mr. Russell, when you guys did the shading stuff, you probably went through and did something like this. And then you came back through on another one and you had to look and say, oh yeah, where's the hash? Like, where's their squares? And it can get gross. Okay. Now, for this, we are not going to do all the hashing and stuff. I have a much easier way than looking for shading and hoping that my art is good enough. Let's pick a function to try. Are we going to start with blue or green or yellow? Let's start with blue. Okay, so conveniently we have all these named right now. Give me a test point that we could try with the blue function. So I'm going to, in blue, I'll test 0, 0. If it's allowed, I'm going to take it. This makes this inequality become 0 plus 0 is greater than or equal to 1. Is that true or is that false? That is way false. Now, here's the challenge. I'm not going to put there, false. Which means, if I can do one of two things, if we can pretend or imagine that the green and the yellow ones aren't here, it'll be easier. But if I have to draw the other ones, I can't. If I have to draw it again with just the green one, I can't. Let's try to pretend these aren't here for now. Green and yellow, sorry. Okay, so check it out. If it is false, what it just says is that no answer in any regions containing the origin will work. Is the origin and this point down to the left or up to the right of my blue line? Nothing down to the left gets shaded then. Like there's no chance of it. What regions do I not even think about shading here? B, C, and D do not get shaded. Can we all agree with that? What regions would get shaded? A, F, G, E, right? Okay, check it out. I'm not going to do hashing. Yes, ma'am.
Oh, wait, why is it not? Oh, never mind.
So because 0, 0 is on this half of the plane from blue, that half isn't shaded. Okay, so no hashing on my part. Here's what I'm going to do instead. I'm going to put a little X in each region that got shaded. And I'm going to put them, just like I did the letters, I'm going to put them on the axes if I need to. So there's one there. I don't know if that one didn't come out weird. One here, and then one down here. Do we all agree those are the 4 regions that would be shaded? Okay, done. Give me another test. Give me a test point for green. And I'm just going to switch colors here because I can tell. -0 plus 0 is greater than 1. True or false? So that's false. Which means which regions would get shaded if only looking at green, it was false down here. Everything here is wrong, so it must be one of these 4. Okay, I'm not going to shade them crazy. I'm just going to put another X in each of those 4. So it could be here. I'm going to make this one over. Could be here, or up here, or over here, or over here. Do we all agree? Okay, yellow regions. Which ones would be shaded? And I'm not even going to pick a test point here. So G gets 1, E gets 1, C gets 1, and D gets 1. Do we agree? How many boundary conditions or functions did we have? Is there a region that got hit thrice? And I can see it because there's very clearly 3 X's inside of this region. Check it out. There's our region. This is our entire solution. Now, there's some other stuff that we could do beyond this. That's way too strong. That's our shaded region. Now, do you think there's any natural follow-up questions that, or things here that I might ask you, or your textbook, or Miss Sweet might possibly ask you guys to identify on this? Anything that you think might be important in this picture? And I know you may not have a good idea. Area, certainly a good thought. Love that idea. It's not the one I was looking for. Any points you think I might ask you to identify? Oh, how would you find that point? What 2 colors would you set equal in use elimination or substitution with? Blue and yellow. Where's this intersection? And you could solve that system. What about this one? By labeling your functions and not losing track of what they are, you can minimize so much of your work. Now, there's no way to get around graphing, like you have to graph them. But I hope that you find this system of like Xing and stuff nicer than the hashing. Okay, color pencils are also a good choice. Okay, I want you guys to do another one on your own or with your neighbors. Questions before I move on? How could I possibly check my answer? You could plug in a point where any point in the shaded region should satisfy all 3 of these inequalities. Now, there's only one nice point in here. It's 0, 1.5. That's the only one that I can see. But I assure you, it's going to make all 3 of these true. Cool. there's something that we're not seeing because AP stuff and I'm trying to hustle through the last of it. If we had minimum and maximum, like if there was some situation happening, you could plug in these vertices, and it's called linear programming. Typically it's done in Algebra 2, where we find them, we plug them into some function, find out what's biggest and smallest. We're not going to do that in here this year. Algebra 2 thing. You might not have done it in Algebra 2 based on the way Christina's looking at me. But okay. All right. So that was a hard one. You guys ready for an easy one?
Sure.
Okay, this is you. On B, and I'm going to switch colors here. One of them is going to be white, and I'm going to go to the pen, and let's check it. I want x plus y is less than 1. Ooh, I love this one. You guys might too. X minus y squared is greater than negative 5. Why? If y equals x squared looks like this, what does x equals y squared look like? Cool. Fusion. There we go. All right. Oh, Dragon Ball Z. Graph and shade. I would resist the urge to take the square root and make the decision of whether it's positive or negative. I would just plug in y's and, plug in y's and see what x value gives you. Cool. Can we all agree the white one, I don't need a graph with you guys? And if you don't agree, that's okay. Just come see me at study hall. Let's see. When x is 0, y is 1. And when y is 0, x is 1. There's my first line, and it always looks like I make a mistake, but we all know that I've never made a mistake in my life. So this is not dashed yet, but I'm fancy. Okay, there's our first one. Second one, walk me through. How can I make sense of this? And I think we talked about this last class, coincidentally, is showing up again. So the 0 idea, I love it. This one's a little bit harder. We could. One more time. You could plug in negative 5 for x, for sure. If x is negative 5, what y does it give me? And I'm going to write this out because for this one, I may recommend, rather than solving it for y, which I'm guessing is what you guys did.
I solved for x.
Love it. How many of you guys solve for x? How many of you solve for y? And then you have to deal with the positive and negative square root, right? Like, however you do it is fine. I would just solve it for x, and I'm going to treat it like it equals. Do we agree this is the same thing? This is a little bit different. Normally we get y in terms of x. This is x in terms of y. Can you pick a y value? And then I'm going to make a table for this really quickly is what I'm going to do. Do you want me to make it yx, so it's like plug in and spit out, or do you want me to do it xy and just write my first one on the right? Does it matter? It feels more natural for me to do this, but I can almost guarantee that even with me saying this, I'm still going to try to plot the wrong point. So let's just try some stuff. Give me some y's to plug in. Okay, 2. And I'll start here. That would give me 2 squared is 4 minus 5. What do I get? So if I go to where y is 2, I get negative 1. What do you think is going to happen, and I'm just going to do this here, if I do negative 2? Oh, it's still 4 minus 5. Okay. That makes sense because parabolas have symmetry. I get those two. Are we cool with that? Give me another y value. 0. Sure. If y is 0, what's 0 squared minus 5? So when y is 0, I need to be at negative 5, and it's going to sneak into here. Sorry. Can you see a parabola for me?
Yes.
Do I need to do any more points? That is the greatest I've ever done on the board. Like, that's... My hand slipped. Okay, how many regions do we have on the board? And I can't even see them all, but that's okay. Okay, so I'm going to be real obnoxious for a second. I see 1, 2, 3, 4, and there's a 5th one hiding. We just can't see it quite yet. Okay. Okay. Last try. Five. Okay. Purely for simplicity's sake, 1, 2, outside is 3, inside is 4, and this is 5. What mistake did I make that I didn't really make, but now I can fix? Those were also dashed. Okay, which region gets shaded? Talk it out with your neighbors, whether you, like, I'd always prefer to see the physical check on your page, but I'm not going to come look at your notes right now. I need to know, is it region 1 or 2 or 3 or 4 or 5? Bless. Now, realistically, while I'm doing these, and just pro tip, once I graph the first line, I already think about the inequality. When I did this first line, I tried 0, 0, and it was true. So everything down here was shaded in my head. So if we're looking at it, if you use the X technique, everything to the left and down of this dashed white line, so it looks like I get an X in this region, I get an X in this region, and I get an X in this region. What about for the second one? Give me a test point for purple. Pink. I don't know what that is. Okay, give me a test point for magenta. Oh, okay. 0 minus 0 is greater than negative 5. True or false? So 0, 0. Which regions get an X in them? 4. Any others? 1 also gets an X. Now, we're done. How many boundary conditions did we have? That's a fancy way to say how many inequalities did we graph with. Is there a region that has 2? Oh my. It's this. It's all of that. Cool. Doable?
Yes.
All right. We've seen only one type of solution so far. Both of our answers have been completely bounded. Now, I don't want to change everything. I just want us to think about it. We don't have to physically do the problem. I just want you to, like, be able to handle it. Show me on your page. I want you to do 2 really quick graphs. You don't even need to give me functions. I want you to try to draw me a system of 2 or more, but at least 2 inequalities that don't have a solution. And I guess that's a weird thing to try to ask you to do because there's nothing to shade. Walk me through how I can draw one that doesn't have a solution. Sorry? So if they don't touch. So if I have 2 lines like this that are parallel, what would I, like, if I know it's weird, but where do I put the X's to show that there's no intersection? Weird. Like, is it possible that I get an X out here to say everything over here gets shaded, and then everything over here? Where's the overlap? So what do you think we would conclude? No solution. What if there's no solution for sure?
Why
Is it
no solution?
because if I shaded above on one and below on the other, is it like we only look for where it satisfies both of them? There's some places where that'll never happen. So if there's no overlap, there's no solution. Could you have infinite overlap? Like, could you have a circle and then secretly disguised as the same circle where it says shade inside on both of them? Or shade outside on both of them? Like, we could do that as well. What if I had this region?
Would that be no solution or no?
That would be just a regular, like, as long as you can find an overlap, you have solution. Yep. This one could be in here, right? That's reasonable. That's probably realistically what it would be. Could it also be at this region out here though and go on forever? Yeah, it's okay if that region goes on forever. Be okay for the no solution if your graphs don't like overlap. That's reasonable. Okay. For the homework, because I am giving you guys an assignment, I'm gonna be honest though, I didn't go read through this. If it says, and I will look at them, I'm gonna write it all down, but I'll probably remove one just so you know. So we have homework. Excuse me. I think I already wrote it there, Miss Sweet. I was good this morning. Homework 7.5, page 515. And you guys get the privilege of problems 16 and 29 through 35 odd. And let me verify that I didn't just destroy this assignment for you guys. because, oh no, linear program doesn't even show up here. We did 16 and 29 through 35 odd. Love it. I'm cool with it. Cool. All right. Trabaja.